Okay, so again, thank you for joining me today. So we're going to talk about specifically kinetics analysis and using FCS Express 5 and kinetics plots to analyze a calcium flux experiment. Okay, so for those of you that aren't familiar with this type of application, um, it's the type of application where ideally what you're trying to do is you're trying to measure the intercellular concentration of calcium ions using flow cytometry. So for the particular data set that we're going to be looking at today, we're going to be looking at data that was collected off of a two laser instrument. The two lasers being a blue and a red. The blue is at a 488 nanometer laser. And specifically, we're going to be looking at two parameters, fluo3 and fluoro-red. The fluoro3 will have a maximum fluorescence at 530 nanometers, about that. And it's going to increase with the calcium concentration. The intensity of the fluoro3 will increase with the calcium concentration, and we'll also be using fluoro-red, which has a maximum fluorescence about 650. And the fluoro-red will be indicative of the background, will decrease as it's with its fluorescence as the calcium ion concentration increases in our experiment. Also during today, what we'll do is we'll talk about how we can create a ratio that can be plotted within our plots in FCS Express and how you can measure the data and get some significant statistics off of that. And we'll be also talking about a lot of different things of how we can do that. Okay. So when we start, what you'll see is that I'm sure many of you are familiar with the traditional plots that FCS Express offers, like dot plots or contour plots or density plots. But what you'll see is if you haven't used a kinetics plot, it's actually it's somewhat different than your traditional 1D or 2D plots. And the fact that these traditional 1D or 2D plots basically will take a cell, it will plot it out according to its X and Y coordinates, and you'll see a dot for each event for each cell that was collected. Whereas with a kinetics plot, what we do is we average all of the Y-axis values per unit of time, and we'll display those averages as a single dot for each X-axis value. And then we'll create a line just to show you how that looks with that single point, okay? Just like with any other type of data in FCS Express, you can use gates to focus on cells of interest, on your populations of interest, and then we can easily apply that to Kinetic Data and get some significant stats out of that. We have many different ways of how we can plot the kinetics data. So as I was talking about how we average out all the y-axis values per unit of time, we have a number of different methods of what kind of statistic we're using to average that information out. Now, just like a lot of the other plots in FCS Express, kinetics plots can be fully formatted. So we can format the overall look and display, what data is being displayed in there. The parameters, we can display overlay data, and we can also display standard deviation for each data point that's within the kinetics plot. We'll also show you how we can display statistics, and we'll talk about some of the tokens that are available with Kinetics data. And we'll also use parameter math to create the ratio that I was talking about between the fluoro3 and the fluoro-red, so that way we can display them on a plot and actually measure it as a plottable parameter, okay? So first things first, I'm just going to go to my empty page, and I have my data list here. So I do want to note that today's webinars, we're just going to jump right into creating a lot of these plots that are specific for this type of application. We're not really going to go over the basics of how to create plots or gates. If that is something that interests you, I highly suggest that you go to our webpage, denovosoftware.com, and go to our recorded webinars page where you can see many webinars and topics about getting started or some of the basic tasks that can be done within FCS Express. You can also find these videos on our YouTube channel as well. But I already have a data file here in my data list, so what I'm going to do is I'm going to create some two plots to begin with. And I can do that just by selecting the file and then just dragging and dropping here on our layout. And when I drag and drop on my layout, FCS Express is going to prompt me for the plot type that I want to use to display this data. So I already have kinetics displayed, selected here, but I'm also going to select color dot plot at the same time. So when I click OK, you'll see here that I have what's going to be a color dot plot and a kinetics plot. So I'm just going to adjust these, move these around, maybe line this up to make it look pretty good. There. Everything's nice and square. Okay, so right away you can see the difference. These are both 2D plots, but you can see that the way the data is plotted within each of these plots is it's different. It's definitely different. Okay, so here we have a dot for the X and Y parameters for each event that was calculated. And as I talked about, the Y-axis values are being averaged out. And what we can do is we can format this within our overlays tab. And we'll talk about that in a little bit too. But just like these plots, what we can do is we can just click on the X or Y parameters. We can change the parameters that we want to display. And then we can see what we can do. We can actually create gates. We can apply gates to these plots, and then we can focus on the cells of population and see what their calcium intake or efflux is like. Okay. So right now, what we'll do is we're going to go to our gating tab, and then we're going to select a gate, and we're going to focus on our cells of interest. So I'm just going to select a gate. I'm going to gate my cells that I'm trying to analyze. So am I creating a gate window? I'll just give these cells a name. I'll click OK. And now I have a gate focusing on my cells of interest. So what I'd like to do is I'd like to apply this gate to this plot just so we can focus on those cells of interest and see what their calcium response is like. Okay. Now I can simply just do that either by selecting the plot and then just choosing the gate from this drop-down menu here from the gating tab, or I can also just take this gate and just drag and drop it. Okay, and then you can see that the gate name is changed up here. Okay. Now on this plot, what we can also do is create some new gates. So I can actually use a marker gate on a 2D plot. And give it a name. And then with this marker gate, I can just move it around. I can focus on the part of the efflux that in which I'm interested. And with this plot, I can also get statistics just by right-clicking on the plot and going to the statistics category. I can select gate statistics, but you'll see that I also have the ability to select kinetic statistics. Now, if I select that, you'll see that we have some special stats that relate just to the kinetics analysis of this application. Okay, but if you're familiar with statistics, the FCS Express, you'll know that by simply right-clicking on that stats box, you can easily edit the information that shows within that stats box, or you could just select Format and go to Stats, and then you can just pick the information that you want. And then you can just click OK, and then whatever stats you selected, they'll automatically show up. Okay, and just like anything else in FCS Express, as you move these around, you'll see that the data is going to change in the stats box. And what's significant here is that you'll see that with this marker gate that I have for my kinetics data, you'll see that some of this information, you'll see that it'll say not applicable. So this information is actually looking to see where the rising phase is. So at this point where my gate is in my data, you can see that there is no rising point. It's basically going to decline or it's starting to flatline. However, if I bring this over here, you can see that FCS Express is able to detect where the rising point is, where it maxes out, and where the efflux is starting to occur. Okay. So with these stats, also come special tokens that we can use for this data. So if you're familiar with this, you know that from the statistics table, we can actually just drag this information right out here, and we can actually look at that number all by itself. So we can actually take this data, and if we have a batch action such as exporting our data to Excel, we can actually pick a value, and we can actually drag it to that batch action. Okay, so you can see that's really easy if you have this experiment that you're trying to create and you're trying to reproduce on a consistent basis. You can see how this would be a great way to standardize the output that you get from this experiment. Also, if I just right-click within this text box and choose Insert Token, I'll insert a statistical token for this kinetics plot. And when I go to the statistics category, you'll see that not only do I have the traditional 2D statistics available, like median, mean for the X and Y axis, I'll also have the ability to choose Kinetic Statistics, okay? And then I can simply just select a statistic to display, and then it'll show this, the same value, okay? Again, if there are any questions, please feel free to enter them in the questions section of your GoToWebinar control panel. Okay, so with this Kinetics plot, what we can do is we can format it. So by formatting, we could just right-click on the plot, we could choose Format, but also one of the new little features of FCS Express is we can just simply double-click on the plot to call up the format window. Okay, so if we click on the Overlays section, on the Overlays category, you'll see that we'll be able to format a number of different objects about this Kinetics plot. So specifically, I'd like to talk about the plotting value. So as I mentioned earlier, these kinetic plots are going to average out the y-axis values per units of time. And what we can do is we can choose which value is being averaged out. So whether we choose a median value or a mean value, we can preview that and we can see what the change is going to be, or geometric mean. And you also see that there's several other options here. I'll talk about a percent above threshold and count above threshold a little bit later on. But what we can also do is we can look at count. And what count's going to do, it's going to show me the number of events per unit of time. So the number of events per time is a great way to look at internal quality control of your experiment to see whether or not there were any air gaps that were acquired with the data, or if there was any clogs within your instrument. What we can do is we can also format this a little bit further, where if we just go below down to our kinetics options and our bin specific options, we can change the resolution to kind of smooth this out a little bit. So that way it's not such a jagged line. We don't have necessarily every value plotted for every bin, but what you can see is you can basically rough out that line and smooth it out a little bit better. And then you can see where the peaks and valleys are a little bit easier. Also from our Overlays tab, what we can do, I'll just put it back on median. And I'll put it back at its original resolution. What we can do is we can have FCS Express display the standard deviation for each plotted event within that Kinetics plot. So from the Overlays tab, you'll see that there's an option for Show Standard Deviation. If you select that, you can click on OK, and then you'll see that the red area will show the percent error or the range of error that you have for each data point. And then as we move our data, you'll see that that information is going to automatically update. Okay, so that would be it's a great way to get some real-time information about your data and the overall status of your experiment. I'll just double click on this and remove this. Okay. Okay, so we talked about inserting plots. We talked about how we can create and apply gates on our data, and we can get statistics and how we can create tokens for our data. We've also talked about how we can format our plot, look at the overlays, and determine what type of plotting method we're going to use for our data. And we've also talked about how we can change our plot resolution for our data. So now what we'd like to do is we'd like to create a ratio for those two parameters that we're talking about. So here, you can see that here we have our FL1, our fluo3 and our FL1 at about 530, and then our FURA3 at FL3 at about 650. Okay, so what we'd like to do is we'd like to create a ratio between those two parameters so we can actually gate it out. And we can put them on a plot like this Kinetics plot, and then look at the data and see how what the ratio is in response to the time and how it all responds to the calcium concentration. Okay, so what we're going to do is we're going to use our parameter math feature to create this type of ratio. Okay, so from our data tab, you'll see that there's our parameter math. So it's important to note that our parameter math is going to create a ratio, and this ratio is actually going to calculate and display the real ratio number. It's not going to just multiply integers together. So what we'll do is we'll actually get a true ratio number, and we can display that ratio number on the y-axis accurately. So by clicking on my parameter math, you'll see that there's a number of ways of how we can create this sequence that can be calculated for our data, okay? So for example, you'll see that there's a single calculation where we can create kind of a one-off calculation where maybe I just want to create this calculation just for this one-time analysis in this plot. So I could simply just select the plot. Underneath the one-off section, just click on single calculation. And in this window, what we're going to do is we're going to give this output parameter a name. I'm going to call this calcium ratio single calc. And what we're going to do is we're going to create the formula that's going to be used to calculate this new parameter. So if we're going to create a ratio between these two parameters, I simply need to select the parameters, the mathematical command, and then what the denominator is. Okay. Once I hit calculate, the software is going to do the math for me. Now if I go over here to my y-axis, you'll see here there's a new ratio for me. So I can actually plot that out. Now with this data, since we're looking at a ratio, chances are a log scale probably isn't really an optimal way to display this information, but what we can do is, again, if we just format this plot, we can go to our axis category, and we can format our x-axis to have a linear response, and we can just do a range of 0 to 1. And by doing that, then you can see that you get you're able to expand your dynamic range a little bit and get a truer sense or a better representation of what your data is doing and how it's responding to that calcium concentration. Okay, so I'm just going to undo that. I'm going to back up. Make sure it's gone. Okay, so now it's gone. So the other option that we have here is the ability to create this as a usable sequence. So if this is an experiment that you're doing over and over again, what we can do is we can create a sequence within this layout as part of this template. Okay, so that way you can load your data, and all you need to do is just run your sequence on your data, and then this new parameter is going to be calculated for you, and then you can just plot out that parameter. We'll also have the ability to export and import this. So if you created this in one experiment and you wanted to import it into another one, you can simply just save the sequence and load it into your new experiment rather easily. Okay. So the first thing we'll do is we'll select Edit Sequence. We're going to have the software perform any calculation on when we load new files in, and then we're going to click on New. And then we're going to do exactly what you just saw with the single calculation. We'll just give it a name. And then we're going to create the formula. So we'll do FL1 divided by FL3. Okay. And then you can see there's a summary of your parameter math formula. We're going to click OK. And then what we're going to do is we're going to go up to the parameter math button again, and then we're going to run the sequence on the top file. So again, there you see there's a new ratio. And again, if I format this plot, I can go to my axis category and just format this to give me a display that's more in tune with the type of information is being displayed within that plot. Okay. So at this point, what I'm going to do is I'm going to insert a density plot. Okay. So with this density plot, what we'll do is we're going to display time on the x-axis, and we'll display the calcium ratio on our y-axis. And what we're going to do is we're going to gate a baseline, and we're going to use this within one of our plotting methods that we were talking about earlier. So if I just go back to my plot and go to my overlay section, two of the plotting values that you see here are percent above threshold and count above threshold. So this gives us the opportunity to look at either the percentage of cells above this threshold that we're going to define, or we can look at the specific count above that threshold. So what we're going to do is we're going to define a statistic for that threshold, and specifically we're going to create a range using a standard deviation based off of our baseline cells. Okay, so within this density plot, what I'm going to do is I'm going to create a gate focusing on this baseline. So anything that's pre the addition of our drug, just gonna move that around. And then what I'm also going to do is I'm going to do a gate based off of our post data. Okay. And what we can do is we can definitely just drag our gate over here so that way we could focus on those cells of interest again. But now what we're going to do is we're going to create a custom token where we can have FCS Express calculate this formula for us. Okay. So from our View tab, we'll click on Custom Tokens. And then we're going to add a new custom token. We're going to call this our Kinetics threshold. So down below, we're going to define the formula for this. Okay. So what we're going to do is we're going to take the median of the y-axis for our baseline gate or our pre-gate, and then we're going to create a range by multiplying the standard deviation for that baseline gate. And the way we're going to do that is simply just by, we're going to drag this pre-gate to our formula. We're going to select y median. Okay. So this token is going to show you the full description of that stat. You can also just right click on it and just show the value. And what we're going to do is we're just going to create a range above that. So we're going to put a plus sign, we're going to put parentheses 2 times the standard deviation for this gate. So I can again just drag this over here, or I could just simply just take this, highlight it, Control C to copy, and then Control V to paste it. And then I could just double click on that number to change that to the Y standard deviation. Okay, and now I will close that. So now if I drag this onto my layout, I can actually see that I'll get an output from that formula. Okay, so what we're going to do is we're going to use this token within the determining of that threshold. And the way we're going to apply that threshold is, again, we're going to go back to this Kinetics plot. From the overlays category, you can see here under the threshold category, we can actually click on this T to insert any type of token that exists in our data or any custom tokens that we've created. So we can simply just click on this. Any token we've created as a custom token will be available here. We can just insert it. And then we can just click OK. Okay. And then what we'll do is, since this range no longer really applies to this data, actually I forgot to change, let's see. So we'll actually change this to above, percent above. Okay, so now we'll actually, again, format this where we go to the axis and we'll change the y-axis to automatic for both the scale and range. And then we should see our events. Okay. And again, we can change this. You'll see that the stats here automatically adjust themselves to suit the criteria. You can see here, if you look at the peak value is telling me it's about just under 85, which seems right about right there. Seems pretty accurate. The thing is about our stats, they automatically adjust to the scale that's being used to display that stat. Okay. And as our data updates, you'll see that that information is going to update because the standard deviation is now updating as well. Okay. Again, if you have any questions, please feel free to enter them into the questions section of the GoToWebinar control panel. So at this point, we can talk about adding an overlay. So I'm actually going to move this over here. I'm done with this plot. I'm just going to put it out of the way for the time being. But what I'm going to do is I'm going to add some more data to our data list. Okay. So I'll add one. And what I'm going to do is I'm just going to add this here, create a new Kinetics plot for that. And by adding this new file, you'll see that the software automatically performed that parameter math, simply because we had selected that option within the sequence to perform on loading new files. Okay. So then we'll just display this just like we did earlier. Check the linear, we'll just do a range of 0 to 1. And we'll set this back from percent above threshold to back to the calcium ratio that we had earlier. Okay, so now what we could do is we can overlay this data on top of one another. So whether we have two different plots showing a different data file, we can actually take one of these, we can just drag it on top of another. And then once we drag it, we can select the second option for Kinetic Chart Overlay. Okay, and then we can just simply add the file as a new overlay. Okay, and then you can see automatically that here in my second data, Kinetics 9 has been added to that as another overlay. What I can also do is I can add more data to my list and just simply take these files and then just drag them on top of this plot. And then I can also choose the option to add the files as a new overlay. And again, the same thing will happen, okay? So again, we can format this as we need to. We can put a legend in here. We can make these lines thicker. We can change the axis display, if we want to choose a different font, or change the color of the font or of the line or the decade markers or whatever the scale is over here. We can do that. We can simply just double click this to open up the format menu. We can go to overlays, and then from the overlays you'll see all the different files that have been overlaid there. You can see that each one had that calcium ratio parameter math automatically performed as soon as we added it. But what we can do is we can take this, we can format this. Maybe we want to make this line a little bit thicker so we can see a little bit better. Maybe we want to put some legend text in here so that way, rather than have the file name appear in the legend text, maybe we want some type of specific text in here. So I can actually do this all at once. Or if I just select a single file, I can simply just edit that legend text. And then this last sample is our positive control. So now if I click OK, actually before that, I'll go to my legend. I'm going to just choose to make it visible. And I'm going to also uncheck the option to resize our chart. I'll move my gate so we can see the legend a little bit better. Okay, so there we have all our data. And then you can see here that we have all the different overlays that were added, and then you can see that the statistical box shows all the data for each of the overlays that were added. Okay. Oh, so to actually go back to the parameter math, what we can do is we can now save this sequence that we talked about earlier. I almost forgot about that. We can actually save this, and we can export it. Okay, so that way you can see here it actually ends it in a .fcf extension. I've already saved one from a previous experiment. So now if I open up a new experiment, I could just simply load that sequence, and it would appear in that experiment for me. And then I can just simply run that sequence without having to recreate that parameter math for the experiment. Okay. So that just about wraps it up for Kinetics. If you have any questions, please feel free to enter them into the GoToWebinar control panel. We'll stay on the line for a couple minutes to see if there are any questions. As I mentioned, this webinar has been recorded, so it will be on display on our website and our YouTube channel fairly soon. We'll just take a couple minutes and then we'll just end with the summary. Okay. So in summary, I just want to say that Kinetics data can be displayed in any plot type in FCS Express, whether it's a single dot plot or a contour plot. And as you saw, there's a specific Kinetics plot where we can average out the y-axis values per unit of time and display that according to whatever plotting value we want to show on the x-axis. The plots can be fully formatted, and we can gate on the data and focus on cells of interest, and we can easily apply those gates to any plot type, whether it's a typical 1D, 2D plot or a kinetics plot. We can easily display multiple overlays within a kinetics plot, either by dragging and dropping one plot on top of another plot, or just taking the data files from the data list and then dragging them right on top of the kinetics plot itself. We can easily create statistics and tokens to show us real-time information about our data. And then we can use that information to export our data to Excel, or if any of the batch actions that we have available to us. We have different ways of how we can plot values, and we can also use our Kinetics plot to plot our data against time, so that way we could use it as a quality control check to see whether or not there has been any air aspirated with the sample, or if there have been any clogs or any gaps in the acquisition of your sample. And then finally, the parameter math allows us to display the actual ratio values rather than multiply integers. And then we can also take that parameter math sequence and we can export, so that way we can import it into another experiment if needed. So if you have any questions, please feel free to contact us at support@denovosoftware.com. If you haven't already, please visit our website, FCSexpress.com or denovosoftware.com, and you can download a free 30-day trial. Also on our website, you can find a tutorial that you can use for our kinetics data, and you can also download data that has kinetics information that you can use for the tutorial. And the kinetics tutorial will use all the tools that we've seen here today. Okay. You can also access the kinetics tutorial specifically from the file menu, from help, and you can just click on tutorials. And then from here, you can see that we will have a specific section for our kinetics information. Okay? Okay. So again, thank you for joining us today. If you have any questions, please feel free to email us at support@denovosoftware.com. I hope you have a good day, and I look forward to hearing from you. Thank you.